In this video, we will be reviewing changes in states of matter, so going from one state to another. This flowchart has the four states of matter. We don't really talk about plasma too much yet. We will be focusing on solid, liquid, and gas for now, and the changes that occur between them. Enthalpy of a system, enthalpy is, you can think of it as energy or organization. A lot of times you'll talk about like order of a system. So solids are typically more ordered than gases. Okay, so order has to do with where the particles are they restricted to a certain area, things like that. First, we'll be talking about freezing and melting points, so the change between solid and liquid and vice versa. So solid and liquid states are both called condensed states. That means that there's not much space between particles in a solid or liquid, so we can't really compress them like we can a gas. When we compress a gas, we're reducing the space between particles. Since there's not really space between particles in solids and liquids, we can't really compress them. Heating a solid is going to result in an increase in energy, so the particles are gaining energy, which we see as an increase in vibration, until eventually the organization of the particles break down as the solid melts. The melting point and freezing point are going to be the same temperature, so that is a point that we reference for a change of state at a given pressure, and those will be equal to one another. At this point, the vibrational energy is starting to overcome the attractive forces operating within a solid. So these are those intermolecular forces that we see between molecules. We're not breaking bonds here, we're breaking intermolecular forces. At the freezing point, the vibrational energy is reduced, so energy is being released from the particles into the surroundings, and as that happens, the attractive forces are reestablished and they overcome the vibrational energy. So opposites are happening here, and it is at the same temperature that this will occur. Next, we'll talk about vaporization and condensation. You'll also hear vaporization called evaporation, even though evaporation is a specific type of vaporization. So this is the change between the liquid and gas states. In order for a liquid molecule to escape into the gas state, the molecule again has to have enough kinetic energy to overcome intermolecular attractive forces in the liquid. So when we're talking changes of states, we're talking about overcoming intermolecular forces, IMFs. If molecules don't have enough kinetic energy, they're attracted back by intermolecular forces to the liquid state. And last, we're going to talk about the solid to gas change, which is deposition if you're going from a gas to a solid, or sublimation, solid to a gas, without going through the liquid state. And this can and does occur often. So solids, just like liquids, have a vapor pressure, but we usually don't think or talk about them because it's so small that we consider it insignificant. But you can see sublimation in some particles. So iodine and CO2 are both common substances that do undergo observable sublimation, so you can actually see it happening. But even snow or ice can undergo sublimation. So you might notice, well, not so much here, but in northern states where there are a lot of snowbanks formed from wind and snow, over time the snowbanks do decrease. So the height of that snowbank will decrease over time, even though we are below the freezing point. So it's not that the snow is melting and then evaporating. There is some sublimation going on. So here again, intermolecular forces are overcome during sublimation and then reestablished during deposition. So those are the main states or changes in states of matter that we will talk about. But we also do want to address the energy in those. So we've obviously talked about changes of states, hopefully before in science classes. In chemistry, we're really relating that change of state to energy. So changes of state always involve a change or transfer of energy. So energy is either gained or lost by the particles, gained from the surroundings or being lost to the surroundings. In general, for particles, gases have higher energy than liquids, which have higher energy than solids. And you can, if you think about the particulate level representation of these states of matter, you can see that solids are limited to vibration and gas particles can be going everywhere in its container. This is called a heating or a cooling curve, and it's not really a curve, it's more like a little hill that plateaus. But here you see a lot going on. So during these slanted sections that are not horizontal, during these sections, the state of matter that is currently in is being heated. So here we're starting, this is for water, but at the bottom we are starting at a solid. So it's a comparison between temperature and I believe it's going to be over time, yeah, or heat added. So heat's being added over time. So here we're starting with solid water or ice. We are heating that water, adding heat to it, and as that happens, the solid is going to increase in temperature to the melting point. Okay, so we can have a solid that's below 0 degrees Celsius, which is the freezing point of water. So before we can actually melt that substance, we have to heat it up to increase the temperature to the melting point. Once we reach the melting point, we kind of plateau here for a little bit. And here, you'll notice that as heat is being added, there is no temperature change. So just because we're adding heat to a system doesn't mean that there's necessarily a temperature change. So what can happen is we can either increase the temperature or cause a change in state. Those things happen independently of one another. Okay, so during the slanted part, we are increasing the temperature. During the plateau part, temperature stays the same, but a change in state of matter is occurring. So here is the melting, okay? So at this point, there's both solid and liquid particles happening. Okay, so this is kind of like your glass of water as it melts. It's staying at 0 degrees Celsius. Then, at this point, we have all liquid. So all of our solid has melted into the liquid state of water. From that point, we are still adding heat over time. So as we add heat, the temperature of the water is being heated. So we can have 0 degrees Celsius water. We have to heat it up to the boiling point, which is 100 degrees Celsius. So at this point, there is vapor pressure happening, but there's no measurable change in state of matter. At this point, we reach the boiling point of water. As we continue to add heat, the temperature remains at 100 degrees Celsius, but we are changing from the liquid state to the gaseous state. So that's what is happening during this plateau. So over time, we have a mix of liquid and gas until finally all of the particles have reached the gas phase, and then we can continue to heat that gas above 100 degrees Celsius. Okay, so it is important to know what is going on in the heating curve, basically when there's a temperature change and when there is a change in the state of matter. So those are the important things for that. We also have something called a phase diagram. This is a comparison between pressure and temperature. So pressure and temperature both affect the state of matter, even though usually we're only, in our everyday life, we're only really focused on temperature. When we boil water for pasta, we're adding heat, changing the temperature to achieve the boiling point. But in reality, pressure also has an effect. So the boiling point at 0 atmospheres is very different than the boiling point up in the mountains or something like that. So phase changes do have a relationship between both temperature and pressure, and the phase diagram shows that relationship. So here we have the different segments, states of matter, solid, liquid, and vapor or gas. The line is the transition between the two. So here is the melting point. So at this given temperature, we need this given pressure for a melting point. Whereas if we have higher pressure, notice that we need higher temperature in order to actually melt that solid into a liquid or or freeze that liquid into a solid. Same for going from liquid to gas or vapor. So at this given pressure, in order to achieve this state change, we need this given temperature. This dot measured T is called the triple point. That is where all three states of matter can coexist. So we have all three phase changing happen concurrently, and this is the critical point. So there does come a point where we can no longer condense gas back into liquid or vaporize liquid into gas. And that is based on the pressure. So no matter what the pressure is, or sorry, no matter what the temperature is above this given pressure, we can no longer condense that gas back into a liquid. So this phase change doesn't occur over this given pressure, no matter what the temperature is. Okay, so that concludes this video. Please let me know if you have any questions.